Now we are going to continue using the previous theorems as we work through these next exercises. So question 3 states, a journalist is writing a story about 3 sculptures arranged as shown below. Where should the journalist place a camera so that it is the same distance from each sculpture? Now, to use and solve this problem, we have to think about a little bit of background knowledge that we have. It's the same distance from each sculpture, and it's circles now. So back in chapter 5, when we were doing triangles, we studied 2 triangle centers. We studied circumcenter and we studied incenter. So with this one to be the same distance, it's probably something to do with the circumcenter, which we know comes from perpendicular bisectors. So I'm going to walk us through this problem. The first thing I'm going to do is I am going to label the sculptures with an A, B, and C, so we have names for them. So I'm going to call this one A, I'm going to call this one B, and I'm going to call this one C. Now, if I connect A to B and I connect B to C, I can see that I now can form a triangle. So using our previous knowledge of perpendicular bisectors, that's what we're going to do. We are going to draw the perpendicular bisectors of those 2 segments. Now I am just eyeballing this, so basically I'm going to just kind of say, okay, that's a perpendicular bisector, and I'm going to extend it up. I'm going to say there's the middle of this one, it's now bisected, and I'm going to extend it up. Now, if you can remember back to chapter 5, equidistant from the vertices, okay? Right there we go. So these are equidistant. So now that is a radius, that is a radius, that is a radius. Well, what is it a radius for? Well, hopefully it is the circle, even though that's not a very good circle, but it's the circumcenter of that circle. So the intersection is the center of the circle. So we're kind of going back to what we already know, that we have created the circumcenter. Now, how does that fit into this chapter now? Okay, well, I need you to notice, if I had a pretty good circle drawn there, that AB and BC are now chords of this circle. So all of this stuff kind of comes together, and everything we talked about, okay, just kind of comes through. Now, moving on to number 4, we have a picture of a circle. It's kind of busy, and it says use the diagram of, this should be circle F, to find EF. So let's identify where EF is. It's right there. And if you'll recall a theorem that we did in the previous video, theorem 10.6, and it said this. It said if the 2 chords will be congruent if they are equidistant from the circle. Well, if you look right here, this is a 12 and this is a 12, okay? So therefore, chords AB is equal to DC. So they are equal. So we know that EF is going to equal FG by theorem 10.6. Now what does that mean for us mathematically? Well, since these are now equal, I can set the 2 expressions that are labeling those 2 pieces equal to each other. So when I solve this, I get 4x equals 8, therefore x equals 2. But that is not my answer. It's asking me to find EF. So I am going to take the 2, and I am just simply going to substitute it in for EF. And 2 times 3 is going to give me 6 for EF. Now, moving on to B, it says suppose that AB is 27. So AB is 27. It says find CD. Well, now since we have these equal, it makes the chords equal. So this is also going to be 27. So CD equals 27. So I really like to say, since circles are so perfect, everything inside the circle that's congruent, they also are perfect. So everything works together. Now, let's look at question 5. Question 5 says the measure of TV, the arc TV, is 121 degrees. So this is the arc. It's asking us to find the measure of RS. So now, if you'll recall theorem 10.3, 10.3 stated if you have chords in the same circle that's congruent, then the arcs, the minor arcs, are also congruent. So simply RS, that arc, is also going to be 121 degrees. Now, question 6, it says just find the measures. So let's first examine and kind of see what we've got going on here. When my picture comes back, so there it is. So it says find the measures. So a lot of things are going on here. A couple of things. A is the center of the circle. Okay, so let me get that going again. A is the center of the circle. And we have perpendicular right here. So we have lots of different relationships going on. So the first thing it says to do is to find X. Well, if you'll notice, since these are perpendicular and it's bisecting this chord, therefore I know that's congruent. And the theorem before said if those were congruent, those arcs are congruent. So I can simply say 4x equals 80 minus x. So I can now get 5x equals 80. So x equals 16. Now, moving on, it now says find the measure of arc CB. Arc CB. Well, we have found 4 and we found the x to be 16. Here is arc CB. So 4 times 16 is simply 64 degrees. Find the measure of BE. Well, we don't have to calculate that because we know those are congruent. So that one is 64 degrees. And then the last one, it says find arc CE, so it's the whole thing. So we simply just add up the two parts, 64 plus 64, for 128 degrees. Now, that right there was utilizing theorem 10.5, so that was 10.5. Now, very last thing we're going to look at, we are going to look at a proof. I always tell you that proofs will never go away. And here's proof that it's not. So question 7 says complete the proof. It says given PQ is a diameter of circle U, so this is a diameter. PT is congruent to QS. Those should also have lines over them. Actually, nope, this is arcs. So let me get rid of those. And the arcs are what's marked in the picture. So the arc PT and arc QS are congruent. And now it's wanting us to prove that triangle PUT, so I'm going to kind of highlight that one here, this little triangle here, is congruent to triangle QUS. So that little triangle right there. So this is triangles. Okay, so now everything we've learned so far kind of comes together with this one problem. We know how to prove triangles congruent. We have side, side, side. We have side, angle, angle. We have many different ways. So I kind of have this one fill in the blank a little bit. So number 1 says PQ is the diameter of circle U and arc PT is congruent to arc QS. Of course, that is given. Number 2, I'm asking you to do a theorem 10.3. So recall what a theorem 10.3 is. It was a biconditional. If this arc in the same circle is congruent to this arc, then that chord and that chord will be congruent. So we can say chord or segment PT is congruent to segment QS by theorem 10.3. Now, we have this congruent here, and now this next statement, there's 4 things it states UP, UQ, UT, and US. Those all four are congruent. Well, what are they? Well, you've got to look inside the circle. They are all radii. So we are simply just going to say radii in a circle are congruent. Those all four pieces are radii. So now what we actually now have triangle PUT is congruent to triangle QUS because we have a side, side, side. Now, again, what has this lesson been over? This lesson has been over circles and how chords, what happens inside with chords. So, if you have a circle, okay, and you have chords inside the circle that are congruent, 10.3 tells us that these minor arcs will be congruent. Now, we also have some with the diameters. If you have a chord here and a chord comes through and is perpendicular right there and bisects it, then we know that this chord here is a diameter. Now, that was 10.4. 10.5 says if the diameter is perpendicular, then these two will automatically happen. It's going to bisect the chord and these arcs. That was 10.5. And then the last one we talked about was 10.6. 10.6 is going to say if the two chords, so like here and here, if those are congruent, okay, then they are equidistant from the center, so you can mark those. So everything in the lesson only deals with properties of chords.